Hello friends, welcome back to the online session of design and analysis of algorithms. In this session, we shall take up the concept of multi-stage graph by using the concept dynamic programming. So the diagram which you are seeing is a pictorial representation of multi-stage graph. In particular, it is a 5-stage graph. So a multi-stage graph G, it is a combination of vertices and edges, is a directed graph in which the vertices are partitioned. The vertices are partitioned into disjoint sets of various stages. Okay, so here v1, v2, v3, v4, v5, these are the sets, disjoint sets. These vertex, the complete set of vertex have been divided or subdivided into various stages. Each and every stage is indicated by v1, v2, v3, v4, v5, like that. If it is a 5-stage graph, 5 stages will be there, and in each stage some set of vertices will be there. Okay, then along with that, there will be a source vertex, yes, and it will be 1 in number, and there will be a destination, or it is also called as sink, denoted by T. At the end, one will be source, the destination will be sink. Source denoted by S, destination is denoted by T. And in between, there are various directed edges in terms of stages. All the edges are directed towards the destination. All the edges are directed towards the destination, but in terms of stages and various interconnections between them. Okay, then. So each set Vi defines the stage in the graph. As I already told, Vi means one particular stage. Okay. Because of the constraint on E means edge, every path from S to T, S means source, T means destination, starts in stage 1. Every edge starts from stage 1, goes to stage 2, then to stage 3, then to stage 4, like that, and eventually terminates in stage K. K means last stage. Whatever the number of the stage may be, all the stages will eventually terminates at the last stage at sink. Okay, I think we have discussed what do you mean by multi-stage graph. I think the diagram depicts the overall meaning of that. So the multi-stage graph problem is to find the minimum cost path from source to destination. What is the problem? What is the agenda over here? From source to destination, we are having many alternative paths in various stages. It's very clumsy if you look at a time. So in dynamic programming, we will find a strategy to find the minimum cost path better. For example, if you just analyze from here, the 2, that is from 1 to 5, that is source is 1, from 1 to 5 it is 2. So it is better to select the minimum path, that is 2. But is it actually minimum cost? Because we must have to think, if I reach 2, I will be reaching 5. Then I cannot go for 2, 3 and 4. Okay, from here I am having only 2 options, 7 and 8. So till the destination I must have to think, not only from 1 to 2 or so first stage to second stage. It is not the only limitations or criteria we are having. You must have to keep in mind all these stages from source till destination. So is this criteria better, or which method to adopt? So dynamic programming, in this multi-stage graph, we'll be discussing some of the strategies to follow such that we'll be obtaining the minimum cost path from source to destination. Okay, this is the overall purpose and agenda of this session. Okay, then. So we'll be having this graph, multi-stage graph. So we'll be having some conventions of using, this is cost, ith stage, jth vertex. Ith stage, jth vertex. For example, if I write cost of 5, 12, what do you mean by that? First parameter is stage number. Second parameter is vertex number. So cost of 5, 12 means cost of 12th vertex at stage number 5. Cost of 12th vertex at 5th stage is the meaning of that. So if I take cost of 12th vertex at 5th stage, it is V5. So cost from itself, node to itself is 0, of course. So and hence I have written it 0. Destination 12 to 12, it is 0. Okay. So initially I'll be writing this cost of 5th stage 12th vertex is 0. And I am making a note of each and every entry in the table now. So this table is very helpful for our understanding purpose. This is the vertex number, this is the cost, and this is D. D means from which node or to which node we are leading to. From 12, I am leading to 12 itself. I am not going anywhere, correct? So this D is specifies to which node it is leading us, to which node it is leading us. So D. So from 12, I am telling 0 to where? To 12 itself. So from 12, from vertex 12 to 12, how much is the cost? It is 0. I am indicating in the table like this. I think this is very clear. Okay, then we shall proceed. So next, cost of vertex 9, cost of vertex 9 in stage 4. This particularly this we are speaking about. What is this cost of vertex 9 in stage 4? This is 4. You can clearly see as per the diagram. So where it is leading us? From 9, where I am reaching? I am reaching 12. So let us indicate that in table as well, like this. From vertex 9, I can reach 12 with the cost 4 like this. It is simple as you are seeing. Okay, then what next? Cost of 4th stage, 10th vertex. Cost of 4th stage, 10th vertex. What is the cost? From 10 to 12, it is 2. So I can write like this. See, cost of 4th stage, 10th vertex cost is 2. Then cost of 4th stage, 11th vertex. So all the vertex 9, 10, 11 are in the same stage, 4, 4, 4. So all this stage, at the 4th stage, I am updating the table in this particular point of time. So from 9, it is cost is 4. From 10, the cost is 2. From 11, the cost is 5. And I am updating. And from 9, 10, and 11, the edges are leading to reach the vertex number 12 that I am indicating in the table. Okay, we shall proceed for the stage 3. Stage 3. I am starting from stage 5. We have started from stage 5, like here, vertex 12, stage 5. Then I came back to vertex 4. I completed. I came, now I will be coming back to vertex 3. Stage 3. V stands for stage number. V stands for stage number. So, okay. From here onwards, we will be following some strategy, because from here on, here there was a direct edge. 4, 9 to 12 it is 4, 10 to 12 it is 2. But from 6, for example, if I consider vertex 6, there is no single path. 6 to 9, 9 to 12, one path option. 6 to 10, 10 to 12, another option. Again, one more option here? No. Right? So 6 to 9 and 9 to 12 is better, or 6 to 10 and 10 to 12 is better. I must have to look till the destination. Not only from 6 to 9 it is 6, 6 to 10 it is 5. Which is minimum? 5 is minimum. So it is better. Is it better to just decide it 6 to 10 is better? No, not like that. Because after reaching 10 to reach 12, is it minimum? Or after reaching 9 to reach the destination, is it minimum? So I must have to consider from 6 to 12, either from this path or from this path. So there is a formula here. We shall follow that. So cost of J is vertex number 6 now. J is vertex number 6. So 6 to 9, R is 9. R is 9. J is 6, R is 9. Okay. So cost of 6 to 9, it is 6 I am representing here, plus cost of 4 to 9. How to read this? Cost of 9th vertex at stage 4. Cost of 9th vertex at stage 4. So what is the cost of 9th vertex at stage 4? It is 4. So I am writing 4. 6 plus 4. Here it is 6 plus 4. Next, or I am having one more option. What is the option? 5. 5 means 6 to 10. Now J is 6. R changes. Instead of 9, now I change the R to 10. 6 to 10, the cost is 5, plus cost of 10 here. Cost of 10 at stage 4. Cost of vertex 10 at stage 4. It is 2. So 5 plus 2, this is 7. So among these two options, which is the minimum? 10 and 7? 7 is the minimum, and hence the cost of 6, vertex 6 at stage 3. How to read this? The cost of vertex 6 at stage 3 is 7, and I must have to update this in the table. From 6, where I am leading? So from we are having two options, from 9 to 12, from 10 to 12. Of course, both are reaching to the destination 12. But from 6, where the edge is leading, the minimum edge, it is leading from vertex. It is leading to vertex 10 of stage 4. Vertex 10 of stage 4. I have obtained the minimum 7 from vertex 10. So this is the minimum. This is the minimum, and hence I must have to update this in table from vertex 6. From vertex 6, the minimum cost is 7. From 6, I can reach out 10 because I know from 10 I can reach out 12 with minimum cost. Like this, I must have to update here. Vertex 6 of stage 3. Okay. Then see, vertex 7 of stage 3, same stage, because in this stage I am having 6, 7, 8. Right. So now vertex 7 of stage 3, what is the cost? Minimum. There are how many options here? 7 to 9, 7 to 10. So both I must have to consider. So this is J, this is R for the first time. Then for the second option, the J remains same, R becomes 10. So what is the formula? As per the formula, yeah, this is 4, cost 4 plus cost of vertex 9 at stage 4. So vertex 9 at, yeah, vertex 9 at stage 4. What is the cost? 4 is the cost. So from here to here 4, from there 9 to 12 it is 4, and hence I am writing 4 plus 4. Then what is 3 plus 2? Here 7 to 10 it is 3. Then what is the cost of 10? Here it is written already in the table. It is ready. Of course, you can look into the diagram, or also you can look into the table. The cost of 10 is 2. So I have to write 3 here. 7 to 10 it is 3 plus cost of 10. This is 2. 3 plus 2 it is 5. So which is minimum now? 5 is minimum. I have updated in the table. Cost of vertex 7. Cost of vertex 7 at stage 3 is 5. From 7 I can lead. The edge is leading us to vertex 10 again. Vertex 10 again. This is updated. Okay. So similarly, cost of vertex 8 at stage 3. So again, I'm having two options, 8 to 10, 8 to 11, 8 to 10, 8 to 11. So which is better? Here 5 plus 2, here 6 plus 5. 5 plus 2 is 7, 6 plus 5 is 11. Which is better? 5 plus 2, 7 is better. So I'm writing 7. And again, this edge is also leading us to the vertex 10. I have updated in the table. I think up till now, it is clear. So vertex by stage, I am coming backwards from front, but the edges are leading to the front side. Edges are leading forward side. Okay. Next, we shall proceed and come one stage behind. That is stage 2. Stage 2. How many nodes are there? 2, 3, 4, 5. All these nodes. Okay. From vertex 2, how many options are there? 2 to 6, 2 to 7, 2 to 8. All these options I must have to consider now. 2 to 6, 2 to 7, 2 to 8. So which is minimum among these, along with the cost from 2 to 6 plus cost of 6, 2 to 7 plus cost of 7, 2 to 8 plus cost of 8, like that. Okay, we shall see. So cost of vertex 2 in stage 2. Cost of vertex 2 in stage 2. How to write? Minimum of 4. What is 4? Cost of R to J. What is R? 2, J is 6. So here to here it is 4. I have written. Then cost of, yeah, it will be helpful in the table. What is cost of 6? You can just refer the table. No need of looking at the diagram, because we have already discussed and calculate. As per the calculation, we have written the table. So if you can just refer the table, you will be getting the cost of 6. What is the cost of 6? It is 7. So from 2 to 6 it is 4, and cost of 6 we can get from the table, it is 7. So 4 plus 7, first parameter. Next option, from 2 to 7 it is 2. Then cost of 7, you can refer the table, it is 5. So 2 plus 5. Then node number 2 to 8, what is the cost? 1. Here it is 1. 1 plus cost of 8. What is the cost of 8? As per the table, it is 7. So 1 plus 7. So 11, 7, 8. Which is the minimum? 7 is the minimum. So from which edge I got this 7? From the second option. Which is the second option? That is from vertex 7. I have got the second option. See, this is the second option. This is the second option. This is the second option. Second option was from 6 and 7 was the second option, and hence I must have to write 7 here in the table. So cost of second vertex at stage 2 is 7, and from this vertex the minimum cost is leading to the vertex 7, like this, and it has been updated in the table. Okay, we shall proceed. So next, cost of vertex 3 stage 2, it has been represented. Cost of vertex 3 stage 2, minimum of how many options are there? 1, 2, only 2 options. Cost vertex 2 was having 3 options, but vertex 3 is having only 2 options, 3 to 6, 3 to 7. So just following the mini already discussed procedure, it has been written. This is 2 plus cost of 6 is 7. Okay, 2 plus 7. Then here it is 7, 7, because 3 to 7, this is 7. What is the cost of 7 from the table? It is 5. 7 plus 5. For the cost, you just refer the table because it is already calculated considering the future paths also. Okay, for cost, you just refer the table. Okay, then which is the minimum? 2 plus 7, 7 plus 5. Of course, 9 is the minimum. We have already updated 9. So it will be leading us to vertex 6. It will be leading us to vertex 6 because we have obtained 9 from first option, because we have leading obtained is from first option. Correct? So 3 to 6, 3 to 7. So it is leading us to vertex 6. Sorry, vertex 6. Next. Similarly, if I calculate for vertex 4, vertex 5, how many options for vertex 4? Only one option is there. What is that? 11 plus cost of 8. What is cost of 8? 7. 11 plus 7, of course, only one option. 11 plus 7, it is 18, and I have updated. From where, from to which vertex it is leading us? From vertex 4 to vertex 8, and hence D is 8. I am writing here. D is 8. I am writing here in the table. Okay, next, cost of vertex 5 of stage 2. This is vertex 5. Only 2 options, 5 to 7, 5 to 8. This is 11 plus 5. This is 8 plus the cost of 8 is 7. So which is minimum? We will be considering as per the calculation, and we will be obtaining the minimum will be 15 as per the table, and it is also leading us to the vertex 8. So at this point of time, this is the table updated by following the same procedure for every stages: stage 5, 4, 3 and 2. Now only one stage is remaining, that is stage 1, which is including the source. If we complete that, we will be completing this table, and from the help of an algorithm or particular logic which has been specified, we shall use this table to find a path from source to destination. We shall see how it is utilized. We shall first complete the stage 1 here. So I think we have discussed the same formula and procedure many times. Please recall and try to accompany me in this. Okay, so cost of j. Okay, what is I? Stage. What is j? Vertex. So cost of 1 comma 1 means vertex number 1, stage number 1. What is the cost of vertex number 1 in stage number 1? So I am having many options. How many options? 1 to 2, 1 to 3, 1 to 4, 1 to 5. 4 options. 4 options have written here. Okay, so this is let me display the table. 9. So 9 plus cost of 2 in stage 2. Cost of 2 in stage 2, because this j, see here, j to r will be there. This is j and this is r. R will be in next stage. Where will the r will be in? Next stage. J to r, I am finding an edge where j will be in stage v and r will be in stage v plus 1. I think it is clear, and this statement is very important as per the understanding of algorithm. If I am finding an edge from 1 to 2, this is j to r. Vertex j will be in stage I, means vertex r will be in stage I plus 1. Okay, this is stage 1, this is stage 2. In whichever stage you consider. For example, if I want to consider vertex 7, okay, if there is an edge from 7 to 9, this will be in stage I. Here I equals 3. Okay, from 7 to 9, 9 will be in I plus 1, means stage 4. Like this, the algorithm is having one of the statement here. Edge from j to r, where j is a vertex at stage I and r is a vertex at stage I plus 1. Okay, fine. Then we shall come back to the first stage vertex from 1 to 2, 1 to 3, 1 to 4, 1 to 5. I have written 9, 7, 3, 2, 9, 7, 3 here and 2 here. Then I have added the cost of 2, cost of 3, cost of 4, cost of 5. What are the cost of 2, 3, 4, 5? We have written 7, 9, 18, 15. Yeah, it is 7. This is 9. This is 18. This is 15. If we add all these 16, 16, 21, 22. So 16 is the minimum, but both first two options are having equal values. Now randomly we can select the, or arbitrarily we can break the tie. We can even select the second 16 or first 16, no issues. Okay, so now as of now, for time being, we shall consider the first 16, first value. That is the, we consider that the minimum value 16 have been chosen from the first option. Which is the first option? Here is the first option. So in this here, yeah, first option is cost of vertex 2 from stage 2. Here vertex 2 from stage 2. You can also choose vertex 3 from stage 2 because it is also having 16. No issues at all, no issues at all. But for time being, we shall consider vertex 2 from stage 2 because this is also giving us minimum. Okay, so here it is 16 from, okay, the cost of vertex 1 at stage 1 is 15. From vertex 1, the minimum cost is leading to the vertex 2, to the vertex 2. So that is also updated in D. That is also updated in D. So with this, following the formula, with the help of the formula and discussion, we have completed and updated the each and every entries in the table. We using this table and following the algorithm, we shall try to find out the minimum cost from source to destination. So this is the algorithm they have asked in the question paper many times. So this is the important algorithm you have to write as it is. This has been given in the prescribed textbook. Okay, so the algorithm is very easy because if you already understood the discussion and the logic, so as per the description, it has been represented once or twice. You must have to just practice of representing in the similar way. So what is the input? Input is the k stage graph, g of which is combination of vertices and edges. Okay, indexed in order of stages because first stage, second stage, third stage, according to the stage they have been indexed. E is a set of edges and c to ij is the cost of I to j. Okay, then yeah, we must have to find a path from 1 to k. K is the level number. If there are 5 stages, 5 levels, so 1 to 5, P is the minimum cost path. So we have to find the P now according to algorithm. So we shall just briefly discuss this algorithm and finish off the session. Okay, fine then. Cost of n. So if there are 12 vertices, if there are 12 vertices, n equals 12. So you can see here in the first concept itself, in the beginning itself, cost of 12 is made 0. Last vertex, nth vertex is made 0. That has been depicted in the algorithm, cost of n equals 0. From then for j equals n minus 1, we started from last 12 minus 1 means n. For example, this, right, 11, 10, 9, we came from back, not from 1, 2, 3 like that. We came from end. So from n minus 1 to 1, we came in the reverse order in step of minus 1. Minus 1 means j minus minus, j minus minus means at each iteration you decrease by 1. In step of minus 1, do what I must have to do within the body of the loop. For loop, it has been given for j equals n minus 1 till j greater than or equal to 1, j minus minus, execute this. What you must have to execute? Same thing, compute the cost of j. Compute the cost of j. In each and every formula, we have done the same thing and that has been discussed many number of times. We shall repeat once again. So let R be a vertex such that, okay, we are calculating the cost of j. For example, j is 1. J is 1. Suppose now we are calculating the cost of j. So how to calculate? So let R be a vertex such that j to R is an edge. So R can be anything here. So 2, 3, 4, 5 all can be considered as R in turn. So this is an edge 1 to 2, 1 to 3, 1 to 4, 1 to 5, which are only having connectivity or which are having edges. We have to consider all that such that what we must have to consider? Cost of j to R. So cost of 1 to 2, cost of 1 to 3, cost of 1 to 4, like cost of j to R plus cost of R. What is cost of R? Cost of 2, cost of 3. We have referred the table, right? We have referred the table, cost of 2, cost of 3, like here. cost of j to r. For example, cost of 1 to 2, it is 9 plus cost of 2. Plus cost of 2 means cost of r, because we have referred the table, it was 7. I have written 9 plus 7. So same thing, it has been represented in algorithm. So cost of j to r 9 plus cost of r. Cost of r we have referring the table at it is 7. So you must have to find that for each and every value of r, and which is minimum, that you must have to select, and you must have to update, the cost of j, cost of 1 equals cost of which is minimum among all the options, you must have to update, that is cost of r, j to r plus cost of r. For example, which is minimum now according to our previous discussion, 1 to 2. If the r value is 2, it was minimum, so I will be updating as cost of 1 to 2 plus cost of 2, that is 9 plus 7, that is 16. 16 is the cost of 1, we have already updated, and the same has been indicated in the instructions or in terms of pseudo code in this algorithm. Like this we find the then the final agenda is to find the minimum cost path, last step. Then see here, P of 1. So P is an array now. We can see by the declarations they have indicated by using an index, right? So this is an array. Okay. P of 1 equals 1. P of 1 equals 1. P of k, what is k? Number of stage. Number of stage. So how many stages we were having in our graph? 1, 2, 3, 4, 5. So in that first stage, P of 1 equals 1. P of 5 equals what they have given in the algorithm. P of 5 equals n. P of k equals n. So k is n. So what's the value of k? It is 5. So P of 5 equals 12. So we shall understand this with the help of one more data structures, that is this table. So we have already built this table. With the help of this table, we'll be finding the minimum cost path. So see here, P of k equals 1. This is P of 1 equals 1. This is the array. These are the indices. P of 1 equals 1 as per the initialization I have done. What is P of k? What is k? Number of stage. K equals 5. So P of 5 equals n. So how many vertices were there? 12. So here I am writing P of k equals 12. So these two initializations I must have to make. First vertex 1, last vertex by last vertex number. Then intermediate, that is 2, 3, 4 I must have to calculate. Okay, because already 1 we have done, it is 1. So I am starting from 2 to k minus 1, because already 1 is done, k is done, remaining is from 2 to k minus 1. What I must have to do? P of j, only this step is remaining in the discussion now. P of j equals, according to this table I must have to pick now, d of P of j minus 1. For example, what is P of j? J equals 2. Okay, now I have to calculate how this 2 comes here. P of j equals, that is P of 2 equals d of j minus 1. What is j minus 1? What is the value of j here? 2. J minus 1 means 2 minus 1, that is 2. So d of 2 means, j is 2. 2 minus 1 is 1. So I must have to refer d of 1 here. What I must have to refer? D of 1. I repeat, P of j equals, P of j means j starts from 2. So P of 2 equals, so I am writing this, equals d of P of j minus 1. What is j minus 1? J equals 2. 2 minus 1 is 1. So d of 1 I must have to refer. D of 1 is 2. And hence I will write 2 here. Again, j plus j becomes 3. Okay, now I will write this. How 7 comes? D of, this is 3 minus 1. What is 3 minus 1? This is 2. What is d of 2? Here, d of 2, this is 7. I will write 7 here. Next, j plus j becomes 4. Now I am writing this. J, P, okay. J minus 1 is 4 minus 1 means d of 3. What is d of 3? Sorry. So here I must have to write d of P of j minus 1. Okay. So, okay. J is 4. J is 4. J minus 1 is 3. P of 3 is 7. And I must have to refer d of 7. I must have to refer d of 7. So what is d of 7? It is 10. And hence I am writing 10 here. I will repeat this in a 2 minutes. Once again, we shall repeat this. Okay. So P of 1 equals 1, P of k equals 5. This is n is number of vertices, that is 12. Okay, once it is initialized, we shall repeat this for loop in 1 minute. Okay, so from 2 to k minus 1, so from 2 to 4 only remaining. So what to write? P of j equals, P of j means P of 2 because j value is 2, equals d of, first I shall calculate the value of inner array, inner index. Okay, j minus 1 is 2 minus 1, P of 2 minus 1 is 1. Okay, what is P of 1 here? P of 1 is 1. So after getting this 1, now I must have to refer this d of 1. What is d of 1? This is 2, and hence I will write 2 here. Next j plus plus, next 3. Okay, so how to get 7 here we shall discuss. So first j equals 3, j minus 1 is 2. What is P of 2? Here P of 2 is 2. After getting this, then I come to d of 2. D of 2. So what is D of 2? It is 7. So I'll just pick it right here. Next j plus plus, j becomes 4. 4 means I am writing this value. 4 minus 1 is 3. What is P of 3? P of 3 is 7. After calculating this, D of 7 I have to calculate. D of 7 is 10. I am picking it and writing this. Now I have completed this path table. Now after getting this table, you can observe in the graph, from this table we have extracted. So from 1 to node 2, node 2 to 7, 7 to 10, 10 to 12. 1 to 2, 2 to 7, 7 to 10, 10 to 12. So it has been indicated in dashed arrow mark or dashed lines. So this path, to obtain this path, this was the method we had followed. Okay, so this array, path array is important. We have extracted from this particular table and it has been indicated. This indicates the minimum cost path from source to destination. Okay, so this concept we had explained is forward approach, because the edge was indicating the forward direction. Of course, we have started from the last vertex and we came back till the first vertex. The approach is called as forward approach. We are having the similar approach called as backward approach. Nothing but we start, for example, here cost of n equals 0, but here b is nothing but backward. B cost of 1 equals 0. Here I am making last vertex value as 0. Here I am making first vertex value as 0. Here I am starting from n minus 1 to 1. Here I am starting from 2 to n. Means from n minus 1 to 1 reverse order. Here 2 to n like increasing order. Okay. Then only the change here is J and R you must have to interchange. Okay. Because you are coming from, not going from J to R, you are coming from R to J here. JR is replaced. C of JR, here it is C of RJ. Okay, again C of JR, everything JR is replaced by RJ because we are coming from in reverse direction. Again, one more thing is from J equals 2 to K minus 1 here, but here it is J from K minus 1 to 2, same here. Okay, so here J plus 1, sorry, here it is J minus 1, here it is J plus 1. So these types of minimum differences will be there. If you just analyze this algorithm by continuing the discussion for some more time, you can easily understand. So many times in the question paper, they have asked you, explain the multi-stage graph with example. Explain the multi-stage graph with example. So with example, they have asked, and forward approach, they have asked to write the algorithm. Backward approach, here it is, they have asked to write an algorithm. So for easy purpose, you can take this simple graph. This is the only simple graph, 1, 2 vertex, 3 vertex, 2 vertex, 1 vertex. So you can use this example for your practice purpose. So I think the session was helpful. You practice